Good day, everyone. It's Alan Schimmel, DevOps.com, and welcome to another DevOps.com webinar. Got a great webinar lined up for today, folks. I'm glad you're with us, and I know some people will be joining as we go. But we have two great guests, courtesy of our friends at Electric Cloud. Before we get into that, let me give you the topic for today, and it's called Doing Cloud Right. 5 keys to becoming an elite DevOps performer. And a lot of what you're going to hear today is based on the kind of groundbreaking 2018 Accelerated State of DevOps report that was based upon the survey and research conducted by the folks at DORA, DevOps Research and Assessment, along with several or many of their sponsors of this year's research and report, and we're going to hear all about it. Before I introduce you to our panelists, though, let me quickly go over some ground rules. We do use the GoToWebinar control panel here at DevOps.com, and it affords us a lot of ways to interact with the audience. One way is that we'll be doing polling questions. There's really just one polling question that we'll be doing today, but nothing gives us sort of hands-on direct feedback quicker than your responses to the polling questions. So when we do ask the polling question, please take a moment, answer the question. It helps our speakers, our panelists understand more about where you're coming from, and it just makes for a much more interactive webinar. We'll also going to try to set aside some time today for the questions at the conclusion or near the conclusion of our slides today. However, don't wait till the end to, ask your question. If you look at your GoToWebinar control panel, and for most of you, it'll be on the right-hand side of your screen, you'll see a section marked questions. And if you expand that by hitting the little arrow or caret, you can see that you could type your question in there. If you're like me, it's a great thing because you don't have to worry about forgetting your question if it's one that came to you early on in the deck today. So please ask your questions as they pop into your mind. They'll be queued. You don't have to worry about remembering them, and we'll get them ready for our panel members during the question and answer time. Oftentimes there's a rush of questions at the end and we may not get to it all. So use the question section. Last, certainly not least, if you're having a technical problem, the audio's not working, the slides aren't advancing, something's working, but you're still able to get into the chat section of your GoToWebinar control panel at the bottom. Please type in your problem there. We do have web engineers standing by who will help you try to get the maximum performance out of today's webinar for you. So again, feel free to use that. Okay, with that being said, let us move on. As I mentioned, today's webinar is brought to us by Electric Cloud, and it is Doing Cloud Right, 5 Keys to Becoming an Elite DevOps Performer. Okay. It looks like we had a little in and out on the audio. I apologize there. Hopefully it'll be better. Let me introduce, well, first let's go over our agenda. What does and here's the agenda, it kind of speaks for itself. What does the 2018 Accelerated DevOps State of DevOps report say about elite DevOps performers? What are the 5 keys to doing cloud right? Why are they so important to DevOps success? And what are useful strategies to adopt? 5 keys and better adopting cloud and microservices in your software release. Let me now take a moment, though, and go over our fantastic panel for today. First of all, I'm happy to have well, they've both been on webinars and podcasts with me numerous times. The guy with the beard to our left needs no introduction in the DevOps world. He's the CTO, co-founder of DORA, author of several great DevOps books, and just all around DevOps guy, Jez Humble. Jez, welcome.
Thanks so much for having me. It's great to be here.
Okay, fantastic. And we got our sound check in. And then joining Jez is another kind of DevOps luminary who has had his share of good times here with us at DevOps.com. He's the CTO of Electric Cloud, Anders Wallgren. Anders, welcome.
Hi, Alan. Great to be here, and always fun to work with Jez. So looking forward to it.
Absolutely. So we should mention that, this is truly a global event with both of you guys over in Europe at different places, and us here down in the southern U.S. and people from around the world listening in, and it's a great time to be alive with technology like that. But Jez, if it's okay, we've gone over the agenda a little bit. I'd like to hand things over to you here at slide 4.
Perfect. Thank you so much. So yes, today I'm going to be spending 15-20 minutes going over the latest research from the State of DevOps report, the Accelerate State of DevOps report that we've worked on. Dr. Nicole Forsgren, the lead investigator, myself, and Jean Kim. It's been running for 5 years now. We've got data from over 30,000 professionals worldwide. We've found that effective software delivery performance leads to high levels of organizational performance. We've investigated what capabilities help produce high software delivery performance. And we've done a lot of statistical analysis to help find out exactly how to benchmark where you are compared to other people in the industry and what factors actually predict high performance, both in terms of software delivery and organizational performance, which can help you get better at what you're doing. So if you move to the next slide, we're going to talk about some of the key themes that we're going to cover. Firstly, we're going to talk about how you measure software delivery performance. And traditionally, we've talked about the software delivery part. This year, we've extended it to also look at operational performance and in particular, availability. So this is a way of measuring how well you're doing, not just at delivering software, but also operating it in production. Then on the next slide, we also spend a bit of time talking about the key technical practices that help drive software delivery and operational performance. So we've revalidated some of our findings from previous years around things like continuous integration, test and deployment automation, trunk-based development, and we've extended it this year to also cover monitoring and observability, continuous testing, how you manage your database changes, and shifting left on security. So we'll cover those in a little bit more detail because obviously those are pretty interesting. Then if you move to the next slide. Obviously, technical practices are one side. It's important also to think about what are the cultural practices that help drive high performance. In previous years, we've used a model of culture produced by Ron Westrom, a sociologist who studied safety outcomes in healthcare and aviation. We've been able to measure culture, measure the impact on culture on organizational and software delivery and operational performance, and identify the factors that can help you improve your culture as well. And we've extended that work this year to also look at how you can positively impact culture through creating autonomous teams and developing trust, and also through creating a culture of learning and using key practices from the agile and safety canons like retrospectives. So we're going to be looking at that too. So that's kind of a high level picture. It's an enormous report and there's a ton of information in it. We're just scratching the surface today. If you want the full thing, you can go to bit.ly/2018-DevOps-report and download your own copy so you can follow along and get the deep dive. So with that, let's go into some key findings. So we look at our highest performing group and we look at our lowest performing group every year and we compare them. And we find that our are deploying 6 times more frequently than our low performing group. They are 2,555 times faster in terms of their lead time from checking in to deploying to production. So that lead time from checking to production, our elite performers are more than 2,500 times faster than our low performers. In terms of being able to restore service in the event of an outage or an incident, they're again over 2,500 times faster in terms of being able to restore. and they have a 7 times lower change failure rate than our low performers, which means that their changes are 1/7 as likely to fail and require some kind of remediation, such as a roll forward or a roll back or some other remediation. So that's kind of the comparison of the high and low. On the next slide, you can see how that's changed year over year. And we actually see, in some cases, a bigger gap. So if you look at change fail rate, that has steadily increased over the years between our highest performers and our lowest performers. Our lead times have remained steady. You can see time to restore service has been a big jump in that this year, mainly because the low performers this year are doing significantly worse in terms of time to restore service, which is an interesting result. So let's move to the next slide. We're going to summarize some of the key differences that we found or that we've investigated in this year's report. So if you just advance a couple of slides here.
Okay, sorry.
No worries. So key differences, we can move straight on to availability. So as I hinted earlier, we've extended our definition of software delivery performance. Traditionally, over the last 4 years, we've looked at 2 key throughput or speed measures, one of which is lead time to go from check-in to release. The other is deployment frequency, how frequently you deploy. And then we've had 2 stability measures. Change fail rate, which is the percentage of your changes that fail. So that's kind of a measure of the quality of your release process, if you like. And then time to restore service. When you have an outage, how long does it take you to restore service? And so that we've added availability this year, which we'll go into a bit more detail. But it's broadly speaking, being able to keep your service up and available, but also being able to make promises to your end users. And we find, we found historically that high performers are not trading off speed against stability. They're not achieving short lead times and high frequency at the expense of change fail rate and time to restore. Instead, we find that the high performers do better at all of these things. That's also true of availability. Elite performers are 3.5 times more likely to have strong availability practices. So if you only take one thing away from this, it should be that high performers are not making trade-offs. They're not only achieving higher levels of speed and stability, they're all as well. This year, when we did the cluster analysis, and again, please move to the next slides, and we can see how things break out.
Jez, yes, if I may interrupt one moment, we had a little bit of an audio drop there. Nothing much we can do about it, but the link for the full slide, I want to get it out to the chat sections here, and it's a bit.ly one, bit.ly/something. If you have
2018-DevOps-report.
Got it.
bit.ly/2018-DevOps-report.
We'll have that out. I'm sorry. And
no, thank you very much. That's
we're
very
doing
helpful.
the best we can on audio. Some things are beyond our control, but we do try.
Yeah. So yes, and what we find here is that this is the breakout of performance between our low performing group, that's 15% of our cohort, our medium performing group, that's 37% of our responders, 48% of the people who took the survey are in the high performing group, and that's bigger than in previous years. We actually see the high performing group is increasing over year, which is great news. It means the industry is getting better. This year we found a new group, that's an elite performance group, that's 7% of the total, and they're able to achieve even higher rates. So if we move forward a couple of slides here, we can see the full breakout.
Okay.
So Alan, if you could just skip forward a couple of slides, then we will get our key performance benchmarks.
Yep. Is this it?
Next one. There we go. Perfect. So there's obviously a bit of a lag as those photons cross over from the Atlantic over to here in England. So what you can see here is our low performing group is deploying between once a week and once a month. That's how frequently they're deploying. In terms of their lead time, it's taking them between 1 month and 6 months to get those changes from version control into production. And it takes about the same time to restore service in the event of an outage. And that might not be getting users back on the website, but it might be restoring full levels of service in the event of an outage. So you might be able to get the website back up, but you might be doing other kinds of remediation like fixing data problems and so forth. And they have these very high change fail rates. Up at the other end, we have our elite performers who are deploying multiple times per day on demand. They can get changes to production in less than an hour. And crucially, in the event of an outage, they can also restore service in less than an hour as well. And that's a very important capability, particularly in the event of some kind of security problem, being able, or some other kind of problem, being able to restore service very quickly is really important. And we see that both our elite and high performing groups, and indeed our medium performing groups, they're able to get this very high quality release process where very few of their changes are actually causing outages. One key topic that we're going to be investigating a lot in this webinar is clouds. And this is the first year we've looked at clouds. So if you can move to the next slide, you can see a summary of what we found. We wanted to look not just at people using the cloud, but how people were using the cloud. And we took our definition of the cloud from NIST, the National Institute of Science and Technology. They have a publication, which is their definition of the cloud, that special publication 800-146. And they define clouds using these 5 essential characteristics. Number 1, on-demand self-service. Teams should be able to access and get access to the resources they want on demand by calling an API. If you have a cloud and you put ServiceNow in front of it, and developers have to raise a ticket and wait a week to get their virtual host or their network change made, it's not a cloud. It's just, some very expensive virtualization data center technology. Number 2 is broad network access. Those cloud resources should be available on any device that you want to be able to access them on. There should be no limits in terms of the network access. Resource pooling. So what that means is we have multiple virtual devices being serviced by a fewer number of physical resources. Rapid elasticity, that means the illusion of infinite resources. I should be able to create 1,000 hosts using an API call as easily as I can create one host. And then finally, measured service, which means I only pay for what I use. So when I get the bill, I'm only paid for the time that I'm actually using those resources. So out of the people who said they were using cloud, only 22% actually agreed that they met all 5 of these characteristics. So less than a quarter of people who said they were using cloud were actually really using cloud according to NIST's definition. However, of that group, those people were 23 times more likely to be elite performers. So it's hard to actually get cloud right and do it in what's often called a cloud native way. But when you do, it really pays off. We see those people being 23 times more likely to be elite performers. So I just want to skip on to a few other interesting results from this year. And again, this is not everything. This is just some key highlights. We looked at open source software. We find that using open source software is correlated with high software delivery and organizational performance. And indeed, if you're using open source software, you're 1.75 times more likely to be in that elite performing group. Those teams are also 1.5 times more likely to expand their open source usage in future. On the next slides, we had a look at industry as well, and we wanted to see if there was any difference between industries in terms of the ability to achieve high performance. We found there wasn't. You can be in a highly regulated industry like banking or healthcare or government, and you're just as likely to be a high performer as people in other industries. So while it's certainly hard to achieve high performance, the fact that you're working in a regulated industry is not a barrier. You can still do it, and we still see high performers in those groups, and indeed people in other domains who are low performers. We even see small companies in the low performing group and big companies in the high performing group. So while it's certainly hard to achieve high performance, you can do it whatever vertical you're operating in. So moving on, let's look at databases. We wanted to look at database changes and find out how to improve the quality of your database changes, and also the extent to which managing your databases in a kind of DevOpsy agile way contributes to software delivery and operational performance. We find that when you integrate your database practices by making sure, for example, that you're storing your database changes in version control, that you're deploying them the same way that you deploy other kinds of changes, and that crucially you're communicating with your database people from early on and throughout the software delivery lifecycle. That predicts software delivery performance. So this is kind of like shifting left. You shift left on your database changes the same way you do with other kinds of changes. Next slide, we look at testing and we find similar results. Again, not just shifting left, but also building quality in by having developers and testers work together throughout the software delivery lifecycle, making sure we're doing performance testing and other kinds of testing throughout the lifecycle, making sure developers and testers are working together. That strongly predicts software delivery and operational performance. Some people think that continuous delivery means getting rid of your testers. That's not the case, but they do have to change the way they work, as we all do in this new paradigm, and that means working together and performing those activities continuously. Then just a little look at observability and monitoring. We find again that good practices here are correlated with stronger software delivery performance. If you have comprehensive monitoring and observability solutions in place, you're 1.3 times more likely to be an elite performer. Interestingly, monitoring and observability, even though they're different terms with different meanings, they were perceived in the same way and as the same thing by people who were taking the survey, which is interesting. And again, there's a deeper dive into that and some definitions of those terms in the report itself. So next slide, you can see a summary of all the technical practices that we looked at, including validating previous year's findings around loosely coupled architecture, which we talked about on this webinar last year, those CI automation practices, and then the new practices we looked at this year, and cloud infrastructure. So next slide, some surprises. And if we can skip one slide on, we actually found in our cluster analysis a group of people, sorry, back one slide, Alan, here, back to misguided performance, thank you. There's a group that actually tries to optimize for releasing infrequently and having long lead times, but spending a lot of time testing and validating before they release. We find that doesn't work. They take a long time to validate everything, but when things go wrong, it's really catastrophic. It takes them months to fully restore service. So this approach of trying to prevent problems from occurring, prevent things from going wrong by spending a lot of time validating, it doesn't really pay off, because when things do go wrong, you're in real trouble. Next slide. What we see is basically as teams move from lower performance to higher performance, they see a dip. As you start to move faster, that exposes a whole bunch of problems that you then have to fix. And if you don't fix those, you don't actually improve. There's a key piece of improving, which is actually fixing the problems you find as you begin to move faster and doing the work to implement these technical practices we talk about. You have to do that to actually get from low performance to high performance. You can't just wave your magic DevOps wand, and you have to actually do process improvement work and technical work. This year, we actually also looked at outsourcing. So this is the next slide. We looked at the impact of functional outsourcing, which means you outsource testing or you outsource operations. We find that that's hugely problematic. Low performing teams are 3.9 times more likely to use functional outsourcing than elite teams, and elite teams rarely adopt functional outsourcing. In the report itself, there's a worked example of the impact of functional outsourcing on performance. So you can actually see some real numbers for yourself on the financial impact of outsourcing. So some major takeaways. Just to conclude, if we can skip forward a couple of slides. So if you want to improve your software delivery and operational performance, it's really important to actually adopt those essential cloud characteristics if you want to see the benefits of that. If you're going to get from being a low performer or even a medium performer to high performance, you've got to make investments in the way you work, in your technology practices, in your management practices, and in your culture. Functional outsourcing is hugely problematic. It's not a good bet. We recommend that you can have distributed teams, but they should be cross-functional teams. And again, there's more research on cross-functional teams in the report itself. And again, high performers aren't trying to move faster and break things. They're trying to do better at throughput, stability, and availability. So that's just a summary. Again, if you want the full report, it's at bit.ly/2018-DevOps report. That's my summary. Thank you very much. I'm going to hand the microphone over to Anders at this point for his section of the webinar. Thank you.
Jez, thank you very much. Just a reminder that bit.ly link is in the chat section of your GoToWebinar control panel. You can click on it and get it right from there. Before Anders comes on, would we like to do our polling question? Anders, is that okay?
Yeah, that sounds great.
Okay, hence the slide polling question. Like I mentioned earlier, folks, please take a moment, answer the question. It makes for a much better experience all around. Today's polling question is, here we go. Okay, what percentage of your organization's mission critical infrastructure is based in the cloud? 10%, 10 to 25%, 26 to 50%, 51 to 75%, or over 75%. I realize that many of you may not know exactly, but your best guesstimate estimate is what we're looking for here. Come on, we only got half of you voted. A lot more people out there. We're going to close voting down in 5, 4, 3, 2. Come on, a few more of you giving some votes. Okay, we're going to close polling. And let's see, Anders, let's see what the results show.
What we got? Interesting, actually. That's a large percentage in the less than 10% slot, but not surprising. Interesting, not surprising.
No.
You know,
actually,
and I think
slower than I've seen in the past. Anders, I've seen that less than 10%, up near 60, 70%. So 42 is not bad.
Yeah, no, and I think it's, you know, I mean, if you look at it, you know, kind of spin it a little bit the other way, you know, almost 60% are above that, right? So it's encouraging.
Yep.
You know, I don't know how scientific our non-scientific polling is here, but I think it's always fascinating to see what people answer. So that's pretty cool.
Absolutely. All right, I'm going to put this to the side, Anders, and we'll get right to your thing, to your half of the presentation here, as we need to save time.
And time we will save.
All righty. Are you good? Can you see?
Right now, I'm only seeing the poll, unfortunately, Alan, but as soon as that fixes it,
I'm sorry, go ahead.
We'll be ready to go.
My fault.
Yeah. So I'm gonna focus, you know, it's getting there, not for me yet. I'm still seeing the poll. Oh, there we go. Perfect. Thank you so much. So, you know, I always say about the state of DevOps report that Jez and Dr. Nicole Forsgren and June Kim and you know, a cast of thousands, no doubt, participate in. It is one of the most powerful tools in terms of working with organizations and individuals, and in really convincing people that, you know, look, the data is there. You know, the outcomes are not guaranteed, obviously. There's still a lot of hard work to be done on these things, but you know, my goodness, the differences between the high and low performers, or the elite performers even these days, is, you know, we don't measure these things in percentages anymore. We measure them in orders of magnitude, and, you know, these days several orders of magnitude, and that really, you know, that has a fundamental and profound effect on the ability of organizations to ship software and you know, and provide value to their customers, and you know, that's really what we're all here for. And a lot of this is happening in the context of huge amounts of, you know, challenges and changes in the way that we're doing software. I mean, you know, I've been sort of calling them tectonic shifts, you know, when I started sort of looking at them as a whole. You know, if we think about application architecture, we've gone from our, you know, monolith architectures to more loosely coupled cloud native, you know, functions as a service, serverless, you know, those kinds of things. In terms of our delivery architectures, we've gone from our kind of, you know, traditional, you know, slightly monolithic, periodic, you know, every few months or sometimes every, you know, few quarters kind of releases, to where we're trying to get to and achieve, kind of the nirvana of continuous delivery, right? That is what many of us are chasing. And at the same time, the operational architectures that we're deploying these things into have changed dramatically. We've gone from, bare metal to VMs, to VMs that other people run, to things like containers and then orchestrated containers like Kubernetes, and then to things like serverless and functions as a service. And I think the one thing I want to point out about this, aside from, kind of the comment there that, hybrid is the new normal, and Jez, I like to steal your line about how, this notion that there's this bimodal IT thing happening is a vast oversimplification, because bimodal IT implies that there's all new and all old. And at least in my experience with the customers that we work with, it's a kind of a hybrid of everything. You have applications that depend on mainframes, that depend on, J2EE stacks, that depend on, microservices and mobile apps, and hybrid really is the new normal. And the idea that you can bifurcate it into the old and the new, I think is a big simplification. But it has massive, impact on how we do these things. And at the same time, the orchestration architecture and all of the kind of software pipeline tools that we have around this have also changed. We've gone from, manual to scripted to that, where we now have, declarative abstract models, star as code, configuration as code, pipeline as code, deployment as code, all of those kinds of things. And so, there's a giant amount of pressure from both the left and the right sides of these things. And of course, we're trying to shift as much left as possible, but there's challenges everywhere. So on the next slide, we'll see the, kind of the message here that, okay, this is really just difficult to begin with, right? If we're just lucky enough to be dealing with a single application, that's great. But the reality is in many large enterprises, we don't deal with single applications. We deal with dozens or hundreds or thousands, sometimes tens of thousands of applications and components. And these things are running in all kinds of different runtime architectures. And the thing that happens as all of the new technologies and architectures get brought to bear is it's a lot like the way we build houses and structures, right? We've learned a lot in the last, 1,000 years about how to build houses. Sprinklers are a good thing, and, dual exits is a good thing. Exit signs are a good thing. But you know what? We don't go and tear down the old houses. We don't go and rip down everything that we built before we knew better, right? Maybe we retrofit them. Maybe we add some sprinklers or things like that. But, we still keep the houses. You go to any city in the world and you'll see lots of old structures and lots of new structures. Well, software is the same way, right? New technologies come along all the time. Docker and containers has taken us a little bit by storm, I would say, Kubernetes and Mesos and those things also. But that doesn't mean that mainframes are going away. That doesn't mean that the traditional monolithic architectures are going away, because frankly, that's where the customers are today. That's where the money is coming in. And, it would be really, really sweet and awesome if we could, change the tires on the car while we're driving, 100 miles an hour down the freeway, but that just isn't practical, nor is it practical to pull over to the side of the freeway and change the tires on the car, because we got to keep going. So all these new technologies come in, and we need to figure out in large IT organizations, how do we absorb them? How do we take advantage of them? How do we manage and do governance around them? How do we adopt best practices? How do we not, just sort of get attracted and sucked into the latest shiny new thing, which may in fact not help us at all, and all of those kinds of things. And really, it's incremental, it's additive. We very rarely get to throw out technologies, right? We very rarely get to toss something out. And so how to control and track, deal with all of the different versions of not just applications, but tooling and infrastructure and those kinds of things, while at the same time supporting our, some of our products that might be, a little bit more beholden to traditional releases, and at the same time dealing with our, maybe some more greenfield type applications, or the applications that we're restructuring or refactoring, or kind of chipping away or eroding the monoliths a little bit, strangling them down to where they're more manageable. That's really a difficult thing to do in the enterprise. And that really, I think, is going to be the challenge for the next decade or so, is managing that along with all the new technologies that come along in that time period. So if we go to the next slide and really kind of start talking a little bit about, the 5 aspects that Jez talked about in terms of, cloud, how do you do cloud right? And I think one of the interesting things in the survey, and I'm not trying to interpret the numbers scientifically here, but it's kind of interesting that we have a rather large percentage of people classifying themselves as high performers, and yet 22%, and that number was 37 or something like that. But yet a reasonably a smaller number of that 22% are actually quote unquote doing cloud right, and that's a big discrepancy, right? That's an interesting thing to see, and we know and see in the data that companies that fully take advantage of doing cloud right really do, they increase their velocity, they increase their quality. We see that there's no false trade-off. There has been and still is, I think, in the industry, this notion that, you can have speed or you can have safety, pick one. And the data shows fairly convincingly that you don't have to choose, but that's a false choice. And there are a number of things that we need to do in order to, in order to really take advantage of that. The first one is this notion of self-service, right? And it's really just a question of, look, what is it that your stakeholders, your members, your developers, your testers, your operational people, your release managers, all of those things, what is it that they need to get their job done, right? They need environments configured so that they can deploy applications there, the application that we're working on testing. We also need to be able to point our test infrastructure at those things. We need to be able to, launch tests, gather the results of tests, process them, keep moving forward in our pipelines, doing all of those things. One of the major situations we find with our customers and prospects in the industry where there's delay is this whole idea of I'm waiting for something. I'm waiting for an environment, or I'm waiting for a build, not necessarily to finish. I don't want to say that CI has a solved problem completely everywhere, but oftentimes what we're waiting for is for that build to be deployed, and not deployed into production necessarily, but deployed for testing, deployed for development. And that's a place where providing self-service, on-demand access to environments, resources, and tools and those kinds of things is a very valuable thing to do in terms of saving time, cutting down on errors, being able to repeatably, reliably push things out into new environments. So that's a major issue to pay attention to in your pipelines and in your environments. On the next slide, kind of the second point around broad access, right, is we need to be able to see these things and operate these things everywhere, and that means not just the product itself, right, because our products these days are sort of multi-platform in the sense that I need to access it on my phone, I need to access it on my tablet, I need to access it maybe on my TV, I need to access it all over the place, and on the back end, there we have lots of platform issues as well, right? We have RDBMSs, we have key value stores, we have all kinds of infrastructure that we run these things on, and in order to deliver that to the end customers, we have to drive it all. We have to orchestrate everything from the very left side of our process all the way through the entire path to production. All of those things in a continuous delivery type of organization are going to be largely automated and largely non-touch, as much as possible. And so, having release pipelines and having CI pipelines and software pipelines and all of those things in place to where you can adapt quickly to things that are changing in your technology stack, things that are changing in your application, things that are changing in how you operate and run these things. Maybe today you're piling these things into VMs and you really want to move them to running as containers so you can get more density out of running these things and do more declarative types of deployments and operational architectures, those types of things. So lots of different ways of accessing these things and being able to sort of fluidly work our way through all of the technologies that we use for these various things. On the next slide, when we talk about number 3, resource pooling, we're really talking about, dynamic provisioning and scaling up and down all across. And that obviously is very interesting for the software in production. It's also very interesting for the software pipeline itself that brings that software, kind of on its path to production. So you want to be aware of the fact that if, when you get to the point where you automate and start to do things like continuous delivery, where you're able to do, very low touch or no touch paths to production, you have to orchestrate, you have to automate, right? You can configure most of those things, but you also need orchestration and automation around them. And resource pooling is something that is not just a concept for production anymore. It's a concept for your software pipeline as well. Because if you're automated and doing continuous delivery, you're obviously extremely concerned that your product stays in production, and you care a lot about that fact. Well, you ought to also care just as much about the fact that your software pipeline infrastructure stays in production. Because if you have to deliver a new version of the software, whether it's to add functionality or react to a vulnerability or something like that, your software pipeline infrastructure has to be up 24/7, just as much as your product does, and has to be elastic with respect to, today we're deploying, 10 different apps to 15 different environments. Tomorrow we have a big CEV, we have a, SSL vulnerability or something like that, and we're gonna have to deploy to thousands of environments and thousands of applications in the next 24, 36, 48 hours in order to mitigate for those sorts of things. So pooling and scaling and elasticity is not just for the application, it's for the entire architecture around which you deliver your application. And it's important to pay attention to that as well. Moving on to number 4, which is really, very similar kind of thing in terms of elasticity, right? You have to be able to scale all of these things out. And I think one of the interesting things operationally that's happening in terms of applications is that we're getting to the point now, and, I think Kubernetes is a great example of this, where you can declaratively say how you want your application, how you need your application to scale out. Here are the various nodes in my application. Here are the various services that I depend on. This application, this service in the application needs to scale in this fashion. This one scales in this fashion, and that's really that's a big change, right? Because that's really going from where we had to do all of this manually before, right? If you really wanted to scale an application up and down dynamically, right? It's one thing to scale up, right? That's not necessarily as interesting, because all you need to do to scale up is either go buy a lot of hardware or spend a lot of money. The interesting part in this, at least from the CFO's perspective, is can you scale back down when you don't need those resources anymore, right? And that's really where you need the automation and the declarative ways of saying, how is it that this application scales? How is it that this application works? And that's really in the last, 5 years or so, gone from being something that is an incredibly detailed, technical, bespoke thing that gets done on the engineering side of things, on the dev side of things, and then on the ops side, it's the same thing. It's an incredibly bespoke, hand-tuned, detailed knowledge of the application kind of thing that happens in operations as well. And now we're really going, towards a model where we can do these things much more declaratively and much more kind of, upfront and with visibility and transparency to all the people that are involved in this. And that's a big deal. That really does change the game in terms of how we talk about architecture and those kinds of things. And so very, very much pay attention to that and very much, get yourself ready for those kinds of things, because it's a massive enabler of velocity to be able to do those kinds of things. And as we move on to kind of the 5th key here, talking about, measured service, right? And what are we really talking about here? I mean, a lot of this is about feedback loops, right? It's really about, how do you accelerate your ability to learn and get better at things? How do we take the notion of, kind of the notion of it's not the quality of the daily work, it's the improvement in the quality of the daily work that matters. And how do we apply that concretely? Well, a lot of that has to do with measurements, metrics, feedback, optimization, finding bottlenecks, eliminating them, really treating this as an iterative process that we go through. And in the old days, the quote unquote bad old days, we got a chance to iterate, every few months, or maybe once a year, or maybe once every couple of years, right? And you know, that's an iteration frequency that is you know, it's essentially undetectable, right? It's essentially useless. If we're gonna, you know, if we're gonna get better at doing these things, or the way to get better at doing these things is to do them more frequently. We all know that, right? Repetition builds expertise. Small batch sizes are good. You know, all of those kinds of things. And so in order to get to the part where you can use the data and feed this back into your processes and accelerate your improvement and accelerate, you know, how good you are at doing these things, you need to do it frequently, and you need to start measuring or continue to measure, and of course also measure the right things. You know, think about outcomes, those types of things. They're really key critical things to do in all of our processes. Excuse me. And then if we go to our next slide, you know, just looking at an example of, you know, what does a pipeline look like in the real world here, right? You know, and we may be looking at where we have, you know, 1 to n different, you know, kind of quote unquote commit pipelines, right? So let's say that we have, you know, we have 5 or 10 or 50 different microservices, all independently developed. You know, they all can reach production directly if they need to, but they all have an independent lifecycle, right? Independent teams, hopefully, if you have enough people to staff them all, right? You know, the reality of microservices is you may not have enough people to staff all of them all the time. You may have to move people around. You may have to call something done and leave it alone for a while. You know, those kinds of things. But then you're also going to have these sort of release pipelines, right? You're going to have integration pipelines and ways that you need to do, you know, some interesting testing when you're moving a lot of things through. And so we've gone, you know, from kind of the very simple notion of our monolithic pipeline, which, you know, we move everything through it every single time, and to deploy anything, we have to deploy everything. To scale anything, we have to scale everything, all of those things, to where we really have lots more moving parts. Now, the good part about lots more moving parts is they can move independently, and we can use different technologies to build them. We can deploy them independently, scale them independently, fix them independently. We can spend different amounts of resources on them. You know, the uptime of our shopping cart and checkout mechanism, the uptime of that is obviously critical, crucial, you know, business, absolutely, you know, critical. The service that shows me my picture, you know, next to, you know, up in the top right corner of the login page and shows my little avatar, you know, frankly, that's not nearly as important. You know, it's probably not worth spending, you know, $1 billion to give you 90, you know, to give you 6 nines of uptime on that sort of service. You know, so it gives you this whole loosely coupled architecture that we're moving to, in general, just gives you more choices and allows you to optimize for each piece separately, which is much better than the kind of, you know, pick one way to do it and stick with it, as we have with the monolithic architectures. And, you know, and if we look at the you know, the next slide, just another kind of example of, you know, what does this look like? You know, what does this look like when we get a little bit you know, more concrete in terms of our pipelines and our environments and those kinds of things? And it's what you would expect, right? I mean, you know, it's checkouts and code scans and building and unit testing and, you know, publishing and talking to, you know, systems like Jira and ServiceNow and Topdesk and all of those things. And then, you know, as we move through the lower environments, you know, kind of left to right into the higher environments, you know, we're getting closer and closer to where we're maybe a little bit more governed. So we're seeing, you know, now we're doing ServiceNow tickets. We're doing a little bit more, you know, kind of service management by TSM ITIL, you know, kind of practices perhaps as we get to the right end of things. You know, and hopefully doing them right in such a way that we don't live in the ticket toil world. You know, that you know, we're properly integrating the systems so that they talk to each other instead of having to have the people feed the beast, which, you know, obviously is not something that any of us want to do. So we can, you know, we can get to the point where we have governance and velocity. And again, you know, I think one of the more interesting things from the findings this year in the State of DevOps report is this notion that there is a little bit of a false choice around this notion of you can't have velocity and, you know, quality or performance or speed or, you know, pick the metric that you want to do. And it is in fact a huge sacrifice to say we're going to go slow so that we can be safe, right?
Yeah, I think
Yeah,
sorry,
go for it.
I just want to emphasize, you know, this is exactly what we see. speed and quality and stability enable each other. And from a governance perspective, it's actually important to be able to get changes through quickly. If you imagine the scenario when there's a CVE and you have to patch all your production systems, lead time is really your friend. So from a governance perspective, being able to move fast, obviously in a safe, reliable, high quality way, is actually hugely important in a modern era where security is a huge concern.
Yeah, and Alan, you can flip to the next slide, which I think has a little bit of the summaries and from our takeaways here, and we can do a little bit more discussion and Q&A. But I mean, I've been hammering on this, since the numbers came out, because so often I hear, and I'm sure you do too, and everybody does, kind of, well, we'd like to go fast, but we're regulated, we're audited, it's safety or it's finance. Those kinds of things. And I don't mean to minimize, those concerns. They're obviously non-trivial concerns for the people in those organizations. But I think we have been kind of trained into this fallacy of you can't have it both ways, and in order to go fast, you have to be good at it, and in order to do things safely, you have to be good at it. So it's not automatic that if you automate, that you're going to be safe, that you're going to be good, all of those things. It clearly isn't. But you have to get a lot of things right in order to do that you also have to get right in order to be able to comprehensively show what you do, how you do it, be governed, be audited, all of those things. And that's, it's really, it's gratifying to see that in the numbers, because it's one of those things that I think all of us have kind of felt like that was intuitive, but, so many things in life that are intuitive turn out to be not so true. So it's nice to see it in the numbers for sure. So I'm just going to sort of summarize here, in terms of the ideas behind doing cloud right. We're very much in this notion of you can't just sort of move to the cloud, right? Lift and shift, we use that word all the time, but be careful about what that literally means, because if you're going to take your 5 gigabyte WebSphere WAR file and run it in a Docker container, yes, you have Dockerized your application, quote unquote, but you are not taking advantage of it at all, right? You're not getting the value of loosely coupled architectures. You're not getting the value of, being able to scale up and down easily, all of those things. So yes, you may be able to check off the box that says, we have a cloud strategy or we have a container strategy or those kinds of things. But you're doing the old way in the new technology. And, at best, the old way in the new technology is no worse than it would be in the old technology, but you're really not going to drive a lot of benefits out of that you're looking for. Start fast and adapt is a big deal, right? I mean, I think so one of the kind of core lessons in my mind about Agile is the notion of don't make decisions when you don't have knowledge, right? Don't make decisions that are long ranging and impactful in the case where you don't have information. And similarly, don't wait to make decisions until you have perfect information, right? Because you never will. And so the idea that, you just need to start, you need to adapt. Just as we want our software to be adaptable and easily refactorable and loosely coupled and evolvable and sort of future-proofed and those kinds of things, the infrastructure that we use to deliver and run all of our software has to be the same way, because they are in fact more coupled than we would probably like them to be, right? The technology that we use, if we're using mainframes, that's going to show up in our software delivery pipeline. If we're just the same way as if we're using Kubernetes, obviously that's going to show up in our software delivery pipeline. You'd like to be able to have that as much as possible under control, kind of under one pane of glass, to where as your technologies evolve, and again, you don't go tear down all the old houses just because we figured out how to build new ones, more safely. We still have to, maintain and live with all the existing technologies. And then, control, auditing, governance, all of those kinds of things. And the more you get into the cloud and those kinds of technologies, especially as you go to things like functions as a service, I think somebody, I forget who it was, might have been Charity Majors, said, I fear that functions as a service is going to be like stored procedures on acid. It's going to be, everybody has their own little function. Nobody knows what the hell they do. And there's 15,000 of them and it's chaos. You know, I don't think I don't think that'll happen. I'm sure there'll be some places where that happens, but you know, don't forget the control of all the complexity, because there's a lot more moving parts, and that does add a little bit of challenge to it. So the visibility aspect of it is big, and then scale and speed is important. So I'm going to stop there, and hopefully we'll have a couple of minutes.
I think we have to.
Chatting and questions.
Anders, I think we're going to have to, because we don't have a lot of time for questions, and we've got a lot of them. First of all, Anders and Jez, thank you so much. This was a great presentation. Let's jump in. The first question is really more of a comment, but it bears a little discussion. It's from Peter, and it's, you know, born in the cloud is easier than lift and shift. Well, of course, cloud native is easier if you're going to cloud than lift and shift. But, you know, Anders, Jez, I think you'll agree with me. We don't have that luxury most of the time, do we?
Yeah, I mean, I think it's that sort of scenario where, you know, that's a live product. It's serving your customers. It's bringing in money. It's keeping the lights on. And figuring out how to evolve that and move forward is challenging, but necessary. Yeah, it is definitely a challenge. And lift and shift is, you know, it sounds so easy. You know, it sounds like, oh, we just put a little elbow grease into it and it's good. And definitely, you know, you want to definitely think in those terms, but you also have to keep in mind that application architecture matters, right? Certain application architectures are more easily able to take advantage of the new cloud native architect or cloud native, you know, technologies. And you have the ability to kind of get a, you know, kind of a false outcome in the sense of, yeah, we're running in the cloud, but you may not be deriving the benefits of it. And I think that shows up in the report this year, you know, just with the, you know, kind of the delta between high performers and those who are really taking advantage of the cloud. And I don't know what if there's any intersection between sort of the elite performers and the extent to which they take advantage of the cloud, but that'd be an interesting, interesting number to look at, and it may well be in the report. I don't know.
Yeah, I mean, there's a nuance here that's important. What we've been looking at is the infrastructure service, not the applications that are built on that. So what we're saying is, you know, from an infrastructure perspective, you have to let your developers, your application dev teams, be able to self-service those resources, have them be metered, and so forth. So in terms of being able to build and deploy on that infrastructure, then it's kind of agnostic to some extent whether you lift and shift or build cloud native apps, as long as you're allowing your delivery teams access to the cloud in a kind of cloud native way, rather than in a traditional data center, you know, raise a ticket, get a request for a new server completed in a month, and you know, that nuance is important, and that nuance is important whether you're doing cloud native or whether you're doing lift and shift into the cloud as well.
Absolutely.
I would also say, you know, lift and shift, there's kind of nothing wrong with doing that, and I think it's a good starting point. And I think, you know, I point people to, in particular, the Strangler application pattern, which, you know, both Anders and I talked about last year on this podcast. The idea that you're not going to move from cloud native, from lift and shift to cloud native in one fell swoop. It's going to be an incremental process. You're going to be migrating your architecture incrementally over time, and you know, to start that journey now, even though it'll take you years to completely migrate to a cloud native pattern. Successful organizations are always incrementally evolving their architecture.
Agreed.
Thanks for pointing that out, because I absolutely, you know, I completely agree. I mean, I think lift and shift, if that's your end goal, that's a bad idea. But lift and shift as the first step of a journey where you start to, you know, take more and more advantage of those technologies. I mean, that's what we need to do. That's what we need to do. So thanks for pointing that out, because that makes a whole lot of sense.
Yep. Guys, we don't have a lot of time, unfortunately. We're at the top. I knew that question was deep. Listen, we've got these in writing. Anders, I'm going to get them over to you, and perhaps you and Jez can get some written responses for the rest of them. There's at least a half a dozen here. With that being said, again,
absolutely.
Anders, Jez, thank you so much. Great presentation. Hey, it's based on some great data from the Accelerate DevOps, State of DevOps survey. So why wouldn't it be a great presentation? Congrats to both of you. Look forward to seeing you both at DevOps Enterprise Summit coming up in Las Vegas this month, right?
That's right.
And
It's gonna be great.
Yep, it'll be another good show. In our audience, if you have a chance to attend, please do so. If not, you might catch some videos on DevOps.com. But for now, this is Alan Schimmel, DevOps.com, DevOps Webinars. Thanks for joining us today, everyone, and have a great day. We'll see you soon on another DevOps webinar. Bye-bye.
Thank you.